Hey guys, welcome back. So till now we have been introduced to data structures and algorithm, whereby we saw what is data structure, what is algorithm, what is the difference between the two, why do we need to learn data structures and algorithm, why are the companies so interested in data structures and algorithms in interview process. Hope all of these concepts are clear. Now with this video, we'll start the next topic, which is recursion. Now if you remember from the introductory video, we said that data structures and algorithm are nothing new in our life. We use them knowingly or unknowingly in our everyday life. So let's try to understand this concept of recursion using a very simple everyday life scenario. So let's say it is a very big occasion in our life and we have received a gift from one of our friends. Now as obvious, we are going to open this gift box. So when we open this gift box, we find another smaller gift box within the bigger box. Now when we open the second gift box, we find another gift box within the second gift box. Similarly, we find another smaller gift box within box number 3 and then box number 4. Finally, when we open box number 5, we find our real gift, which is a golden ring, which was awesome. Now this situation of opening a gift box multiple times, is it equivalent to a recursion in data structure? Let's see. So when it comes to recursion, there are three basic properties that it follows. That is, first of all, we have a operation which is performed multiple times with different input. Now in case of our gift, we had this operation of opening this box. And we perform this operation of opening the gift box multiple times. But every time we opened the box, it was with a different input. Now what was the different input? It was a altogether different box. So first we opened this box, then we opened this box, then we opened this box, and so on. So we opened 5 different boxes. But the process of opening all these boxes are always same. That is why we are saying same operation is being performed. Okay. Now let's see what is the second property of recursion. Now the second important property of recursion is that in every step we try to make the problem smaller. Similarly, in case of opening the gift box, we tried to make the problem smaller. So first we opened the bigger box, then the next smaller box, then the next smaller box, and so on. Now why we are making the problem smaller? Because that is the way we will find our final answer, which is rings in this case. Now let's see the last property of a recursion. So the final property of a recursion is we mandatorily need to give a base condition which tells the system when to stop the recursion. Now what is a base condition? Base condition is basically the condition after that we will not do any more recursion. We will stop the recursion because we either would have found the answer or the answer does not exist. So in this case of a gift box, we opened first box, second box, third box, fourth box, fifth box, and at the sixth iteration we found our gift, which was ring. So we stopped the iteration on the sixth iteration. Now you might be wondering that what if we don't give a base condition? What is the problem? The problem is that in that case, how will the system know when to stop the recursion? Hence, in that case, we might end up in an infinite loop. So to avoid that condition, we should always have a base condition. Fine. So I hope you have understood the concept of recursion. Now let's see how does recursion looks like in data structures world. So here we have a binary search tree which is rooted at number 8, and we want to find out if number 4 is there in this tree or not. Now what is a binary search tree and what are the different operations that we can perform on binary search tree? We have talked about it in lot of details in the tree chapter. So in case if you have missed it, I will highly recommend please watch that video first and then come back to this video. Fine. So now let's quickly recap how do we find a value in a binary search tree. So the algorithm is simple. If the value that we are trying to find is equal to the value of the current node, in that case we return the current node and the method ends. Now in case the value that we are trying to find is less than the current value, then we go to the left subtree. On the other hand, if the value that we are trying to find is more than the current value, then we go to right subtree. Once we reach the subtree, then we again perform the same thing. That is, if the value that we are trying to find is less than the current value, go to left subtree, else go to the right subtree. Now once we reach the subtree again, we do the same thing. If the value is less, go to the left subtree. If the value is more, then go to the right subtree. So if you closely observe, we see a recursive thing over here. That is, every time the subtree changes, but the conditions or the formula remains the same, which is if the value is less, go to left. If the value is more, go to right. Now can we form a recursive formula or a method to find or search a value in this subtree? So yes, we can write a simple recursive method here. So the name of the method is search. It takes a root reference and the value that needs to be searched. If the root equals null, that means if the root does not exist, then there is no question of searching. So we simply return a null indicating that the value is not there in this tree. Else, if the root's value or the current node's value is equals to the value that we are looking for, then we are good. We simply return that current node. Else, if the value that we are trying to look is less than the current value, then we have to go to the left subtree. And in case if the value we are looking for is more than the current value, in that case we go to the right subtree. So we see that we have used search operation twice in this method, which is nothing but a classical use of recursion. So I hope that you have understood what is recursion. Now let's quickly recap the properties of recursion once again. So property number 1 was same operation is performed multiple times with different input. So we have seen in our algorithm, we have used the same operation, which is search method, twice in this current method, which is search. But the inputs in both the cases were different. Previously we were using root, but when we are calling it recursively, we are calling it with a different input. Root.left in this case and root.right in this case. Now the next property was, in every step we try to make the problem smaller. So did we make our problem smaller in every step? Yes, we did. So in every step, we are calling either root.left or root.right. So effectively, we are actually reducing the size of the problem into half every time. So in case if we are going to root.left, we have eliminated the entire right subtree. Similarly, if we would have come to the right subtree, we would have eliminated the entire left subtree. So basically, in every step, we are making the problem smaller. Now the last property is we mandatorily need to give a base condition. So did we give a base condition here? Yes. So these two lines over here are nothing but the base condition. That is, if root is not available, return a null and don't do any more recursive calls. Or if the current value is equals to the value that we are trying to search, in that case return a root and don't do a recursive call. So those were the two base condition over there. Fine. So I hope you have understood recursion on a very high level. In case if you still have doubt, nothing to worry. We are going to talk about recursion in lot more details in the next videos. So please keep watching. So with this, we come to end of this video. In the next video, let's talk about why do we need to learn recursion? Is not a plain iterative method good enough? Let's talk about it in the next video. Thanks for your time. See you in the next video.